Time to do our hypothesis test for Chapter 10, Section 4. It's testing ANOVA, or analysis of variance. The problem that we're going to use as an example is number 5 on page 565. Again, null and alternatives are prescribed. Your null, and you can modify it a little bit, but it's just basically all means are equal, and the alternative is at least one is different. When you read problem 5, you'll see that the alternative is the claim, and what you're going to need to do is take the data and plug it into your lists. So you're going to do stat key, you're going to hit the edit button, or the edit, I don't know what you'd call it, option, there we go, and then your L1 will be the data from very good, your L2 will be good, and your L3 will be the fair. Now you have to generate 2 degrees of freedom in order to be able to do this. Your first degree of freedom is called degrees of freedom of your numerator, or df sub n, and what you do to get that is the number of categories, k. I'd rather use c, but okay, the number of categories k minus 1. And so that's 3. We have 3 categories of means, the very good, the good, and the fair. 3 minus 1 is 2. And then you also get degrees of freedom of denominator, which is the total number of observations, which in our case is 15, minus k, which is 3, which gives us 12. All right, now here's where you have to be careful. There are 5 or 6 tables that are for the F distribution. Again, you've got a right-tailed test, but you've got to choose the correct table based on your level of significance. Bear with me for a second. In our problem, our level of significance is 0.05. So when you go back to the tables, I'm going to hold one up here. You've got to look along the top, and you've got to see if that says 0.05 or 0.005 or 0.01 or 0.10. And the problem is that I have students on tests that'll look at 0.01 or 0.001 and they'll mistake the two. So please be careful there. Grabbing my board back. So, first of all, get the correct table, the 0.05 table. Then, degrees of freedom of numerator was 2 again. Degrees of freedom of denominator was 12. The 2 runs along the top. The 12 runs vertically. And you should get a critical value of 3.89. See if you can find that. Next, after you've entered this data into L1, L2, and L3, you're going to go stats, then tests, and then you're going to look for ANOVA. And then to get it to run on the data that you put in, you're going to hit the second key, number 1. Now you should see ANOVA and then the L1. Hit comma, which is right above the number 7. Then do the second key, number 2. That should say L2. Then hit the comma, again right above the 7. And then hit the second key, number 3, and then close it off with parentheses. Hitting enter, you should get an F statistic of about 4.8. It's like 4.79 something, something, something. I just rounded up. Okay. Your p-value should be about 0.029. Okay. That means that was my daughter talking to my dog. My apologies. That means the test statistic is in the rejection region. Our p-value is smaller than our alpha of 0.05. So that means we do 3 things. We're going to reject the null. So we go up here, we say, yeah, the null is no good. Okay? Actually put a line through it. Our alpha is 0.05. We always state our level of significance, and then we make our statement regarding the claim. Since the null got crossed out, the claim still exists. It's being supported. So we say there's sufficient evidence to support the claim, and then we restate the claim. Hopefully that helps.